The concepts that I will be covering in this video today are secant and tangent lines, their respective relations to functions and to each other. I'll be discussing what their slopes can tell us about functions, and how you can use the slope of the secant line to estimate the slope of a tangent line. We'll begin by discussing secant lines. The simplest way to think about a secant line is to imagine a line that passes through 2 points on a function, connecting them. To get a little more complicated, the secant line is the average rate of change, or slope, between the 2 points on the function that it connects, in this case points 3, 1 and 5, 5. To calculate this rate of change, we simply plug in our point values into the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. In our example here, the average rate of change is positive 2. The average rate of change of secant lines can be used to estimate the slope of tangent lines, or the instantaneous rate of change, but we'll come back to that a little later. A tangent line, on the other hand, only intersects with a function once, shown here at point 3, 1, and represents the instantaneous rate of change. As we saw from the last slide, the average rate of change between points 3, 1 and 5, 5 is positive 2. But that is just the average slope between 2 points on the function. What if we wanted to know the slope of one specific point? This is where tangent lines come in. Another way to look at it is that a tangent line shows the steepness of a specific point. As you can see in this graph, as we take the tangent of each specific point on the curve, the line becomes slightly less steep. At 5, 5 it is very positive, at 4, 3 it is less positive, and at 3, 1 it is even less positive. That means we are seeing a larger rate of change for y with respect to x as we move right along the function, and a smaller change in y with respect to x as we move left along the function. In this next slide, I want to begin discussing how we can use the slope of secant lines to estimate the slope of a tangent line, and for that I will need to use a different equation and graph. This is the graph of y equals x squared. On it, I have drawn the points 1, 1, 2, 4, and 3, 9. If we were going to try and estimate the slope of the tangent line at point 2, 4, first we need to talk about the concept of h. H is the difference between the x values of two different points on the function. If you're thinking about rise over run, h would be the run. In this example, where b equals x sub 2 and a equals x sub 1, h would equal b minus a. Therefore, b f of b can be rewritten as a plus h, f of a plus h, and the slope formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1 can be rewritten as f of a plus h minus f of a over a plus h minus a, which itself can be simplified to f of a plus h minus f of a all over h. So going back to our new equation, I've gone ahead and drawn in h between point 2, 4 and the outside points of 1, 1 and 3, 9. Now it stands to reason that as we move along the graph towards point 2, 4 from either side, h is going to get smaller. One way to think about this is that h is approaching 0. Now, as the h value approaches 0, the slope of the secant lines gradually approaches the slope of the tangent lines. By applying this theory and substituting values into our original equation, we can approximate the value of the tangent slope using the new version of the slope formula we just covered, f of a plus h minus f of a all over h. I've gone ahead and drawn out a table here to show what I mean, approaching first from the right side of the equation and then from the left. So what I've done is substitute in a slightly larger value of x to represent x sub 2, in this first case 2.5, then taking the corresponding value of y, in this case 6.25, and plugged all of those into our new slope formula over h, which in this first case is 0.5. The first case shows a secant line between points 2, 4 and 2.5, 6.25, which is a slope of 4.5. By gradually reducing h closer and closer to 0, I can approximate the slope of the tangent line at 0.24 as 4. Just to check my work, I'll go ahead and try approaching it from the left as well. So, as you can see here, the math does in fact check out, and the approximate slope of the tangent line at 0.24 is equal to 4.